All right, this lesson deals with isosceles and equilateral triangles. The front page will talk about the isosceles, and then on the back page we'll hit up the equilateral triangles. All right, so the first part of your notes, we're going to talk about specific pieces of an isosceles triangle. These two congruent pieces on the triangle are called the legs. And the angle where the two legs meet at, this is called your vertex angle. So angle B is the vertex angle. The angles across from the vertex, which would be angle A and angle C, these are called your base angles. So angle A, angle C, base angle. And then the segment in between the base angles is just called your base. So you got two congruent legs, you have a base side, you have two congruent base angles. So we need to know that angle 2 is congruent to angle 3. And put those little arches in there to show congruency. So two congruent legs, two congruent base angles. Your isosceles triangle theorem states, if two sides of a triangle are congruent, then the opposites, those sides, are also congruent. So in the example, we can say that if AB is congruent to BC, then I know that angle A is equal to angle C. And then the converse just flips it. So I can say if angle A is equal to angle C, then AB is congruent to BC. Just know that if you have congruent base angles, you're going to have congruent legs, and vice versa. If you have congruent legs, then you're going to have congruent base angles. So let's look at some examples. 107 says, apply your knowledge of the sides and angles of an isosceles triangle. All right, number 1 wants angle J. So right away I noticed that I have two congruent sides, which means I'm going to have two congruent base angles. So if L is 68, J has to be 68. And then to get angle K, just remember that if you add up all the degrees inside of a triangle, that is to 180. So if you take these two guys, add them up, subtract from 180, you have 44 degrees left for angle K. K is 44, J is 68. Number 2, I notice once again I have two congruent legs, which means I'm going to have two congruent base angles. And then to get those, I know the angles inside of a triangle have to add up to 180. So take 180 minus the 106. That leaves you with 74. And then I have to divide that by 2 to get the two remaining base angles. And when you divide that by 2, that comes out to be 37 degrees. So angle C is 37 and angle E is 37. Number 3, I notice that I have two congruent base angles, which means I'm going to have two congruent legs. So if XY is 12, that means YZ also has to be 12. And then to get angle Y, just remember that all three angles inside of a triangle have to add up to 180. So add these two up, subtract from 180. And for angle Y, you are left with 26 degrees. Some algebra. Number 4, I notice I have two congruent sides, which means I'm going to have two congruent base angles. So since they're congruent, for the equation, set them equal to each other and solve for x. So 8x minus 30 is 5x plus 9. Subtract 5x from both sides. Add 30 to both sides. Divide by 3. X is 13. 5, same thing. You have congruent legs, which means you're going to have congruent base angles. So the same thing as number 4, set them equal and solve for x. 4x plus 7 is 9x minus 33. I'm going to subtract 4x from both sides. Add 33 to both sides. And 5 goes into 40 8 times. Number 6, this is the converse. if you have congruent base angles, that means you're going to have congruent legs. Set them equal to each other, solve for x. 15x plus 7 is 23x minus 17. I'll subtract 15x from both sides. Add 17 to both sides. And 8 goes into 24 3 times. Number 7, once again, I notice I have congruent base angles. That means I have congruent legs. So the legs equal to each other and solve for x. 9x minus 73 is 3x plus 23. Subtract 3x from both sides. Add 73 to both sides. And 6 goes into 96 16 times. Backside. All right, for numbers 8, 9, and 10, I suggest you draw a picture, draw the triangle, and then we'll label the angle so we kind of know what we're looking at here. So for number 8, we're going to draw a triangle RST. And then we'll look at the directions. It says that, hey, RT is congruent to ST. Let's mark it. And then right away, I also know, since I have congruent legs, that angle R is going to be congruent to angle S. All right. And then it gives us all 3 angles, angle R, angle S, angle T. We got to solve for x and plug it back in, right? So my diagram, I know I'm going to set angle R equal to angle S since they're congruent. So 9x plus 2 is 13x minus 18. Subtract 9x from both sides. Add 18 to both sides. And then 4 goes into 20 5 times. And then when you plug it back in to all the pieces, R comes out to be 47, S is 47, and T is 86. 9, same thing, draw the picture. Triangle D, E, F. Directions, angle D is congruent to angle E, which means that this piece is going to be congruent to that piece. Opposite the base angles, the legs are congruent. All right, so I'm looking for DF. I'm going to set that equal to FE. Here's DF. Here's EF. Set those equal because they are congruent to each other. So 4x minus 8 is 7x minus 35. Subtract 4x. Add 35 to both sides. And then 3 goes in there 9 times. Then we got to plug it back into all the pieces. DE comes out to be 13. EF is 28. And DF is also 28. 10, same thing. Draw the triangle. Triangle X, Y, W. Directions. WX is congruent to WY, which means angle X is congruent to angle Y. Directions. I'm looking for angle X. I'm going to set that equal to angle Y. There's angle X. There's angle Y. Set them equal. 5x minus 12 is 7x minus 48. Subtract 5x. Add 48 to both sides. And then 2 goes in there 18 times. Plugging it back in to all the pieces. W is 24. And X and Y are both 78s. All right, equilateral triangle, super easy section. Says a triangle is equilateral if and only if it is equiangular. That means if all angles are the same, that means all sides have to be the same as well. So if angle A is equal to angle B, equal to angle C, then I can say segment AB is equal to segment BC, which is also equal to AC. Then the converse, you just flip it. If the sides are all equal, then the angles are all equal as well. All right, 3 more problems. When you're dealing with equiangular / equilateral triangles, every angle inside one of these triangles is always going to be 60 degrees. Every single time. And we also know that all sides are congruent. So if one side is 9, they're all going to be 9. Number 12. It just wants a measure of all the angles. Well, I noticed that it's equilateral, which means it has to be equiangular. So all angles have to be 60 degrees. 13. It says your triangle is equilateral, which means all sides are congruent. And we got to solve for x and we got to solve for y. To solve for y, just pick any 2 of the 3 sides and set them equal to each other. I'll pick the 14y minus 59. I'll set that equal to the 9y plus 1. I'll subtract 9y from both sides. Add 59 to both sides. And then 5 goes in there 12 times. To solve for x, I know that every angle is equal to 60 degrees. So I'm going to set this stuff equal to 60 degrees. 7x minus 3 is 60. Add 3, 7 goes in there 9 times. That is it for isosceles and equilateral triangles.